As the slide shows, I'm going to be talking about unconventional oil, in particular two of the plays. These unconventional oil plays have been significant in increase in the daily production, as Scott mentioned. The two plays I'm going to talk about is the Bakken, again, which was mentioned, and the Eagle Ford, which is in South Texas. The Bakken is located in northern U.S. and across the border into Canada. These plays require new drilling techniques, unlike conventional reservoirs. And these techniques have been developed over the years for the last 5 to 10 years, and these techniques of drilling and completion will continue into the future. Scott showed this graph. It's the U.S. oil production from 1920 to the present. I'm not going to say a whole lot about it except for the sharp increase to the far right of the graph. That's primarily due to the Bakken and the Eagle Ford, and how the development drilling made the decline over the last 40 years less, and then the sharp increase in the last 5 to 10 years. These current rates that we see due to high oil prices and the Bakken and the Eagle Ford makes our current daily production about equivalent to what we see in 1970. These two unconventional plays that I'm going to talk about, Bakken and the Eagle Ford, together they account for about 1.7 million barrels of oil a day over the last increase of daily oil production over the last 5 years. Okay, let's look at the tail end of the chart. This is kind of a blow up of the first chart, and it represents the impact of the daily oil production from the Bakken over the last 10 years. Starting in about 2003, there was a gradual increase in the number of wells and the associated crude with these wells. New drilling and completion techniques in these early wells was developed by the operators and the service companies. During the first 5 years, from about 2003 to about 2008, around 700 wells were drilled and increased daily oil production from the Bakken by about 100,000 barrels per day. During the next 6 years, however, from 2008 to the present, more than 7,000 wells have been drilled, and the U.S. daily oil production witnessed by this additional increase has been approximately 900,000 barrels of oil a day. That's substantial over the last 6 to 7 years. The sharp increase in daily oil production is due to the understanding of the Bakken formation in the daily production and the new drilling techniques and the completion techniques. The sharp increase will continue from 2014. As you see, the chart stops in 2014, but we believe the daily oil production, don't have the exact figures, but it's close to about 1 million barrels of oil per day from just the Bakken alone. Let's take a look at where the Bakken formation is located, how large is the play, and what does it look like on the log when you drill a well. The small index map gives a general outline of the aerial extent of the Bakken and where it's found. That's found in the lower left-hand corner of the map. The red box inside the index map shows that the Bakken covers over half of North Dakota, extends into western parts of Montana, and into the southern section of Canada. Significant oil fields have been highlighted on this map, and these have been the sweet spots, as we call them, in the Bakken formation. Note the scale on the large map. The aerial extent of the Bakken extends for tens of thousands of square miles. That's very hard to envision, but very large area of the Bakken formation. Recently, numerous operators have been drilling step-out wells from the known oil fields, trying to find other sweet spots, and they're finding mixed results from the daily oil production rates of the Bakken. However, because of the large aerial extent of the Bakken, I'm sure other sweet spots within the Bakken formation will be discovered in the future. On the right-hand side of the slide is what the Bakken looks like on a log. Although everyone calls it a shale play, it's really a mix of different types of rock formation. different types of lithology. The upper and lower parts of the Bakken, they are pure shales. But in the overall geologic interval, you'll often find dolomites, limestones, sandstones, and that's all within the middle member. In order to get a really good Bakken well, high production rates, you need a good middle section. A well that logs just shale in the Bakken would typically be a much poorer well. These two charts represent how and how much a Bakken well would typically produce through time. The upper right chart is a type curve for the Bakken well. A type curve is constructed from the oil production from many wells through time, and it's like an average. As the type curve shows, a typical Bakken well will start producing at a high daily rate from day one, but during the first year of production, like Scott mentioned, the oil rate declines substantially. However, what makes the Bakken well so good are the flattened decline rates you see after the first year for the remaining life of the well. This type curve indicates that a well will have a high rate of return, pay out in 1 or 2 years, and still produce for 35 to 40 years, with ultimate recovery of 500,000 barrels to 700,000 barrels. These economics are run on a little higher oil price, but still, today a Bakken well can be a good well, even with today's oil prices. On the chart on the left, lower left-hand side, it's a oil production for many wells that vary the well-to-well spacing. How close should each well be to each other? Operators are continuing to refine the spacing, but currently it appears that the well spacing of less than 3,000 feet have much higher daily rates than the wells greater than 3,000 feet. But determining this best well spacing is still ongoing, and it's an issue in the Bakken. As the title says, why all the excitement about the Bakken? Harold Hamm is the CEO of one of the major players in the Bakken, Continental Resources. It's a very large accumulation of oil, over about 15,000 square miles of the Bakken Formation. They believe about 20 billion barrels of crude oil are in place, and an additional 4 billion oil equivalent in natural gas. 320 acre spacing, the wells will produce about 500,000 barrels each. It's believed it could take up to almost 50,000 barrels to develop the Bakken, with only about 90% left to be drilled. Only 10% of the wells have been drilled. 4,000 of these wells, current wells, are horizontal, and today most wells will continue to be horizontal. With 170 active rigs, we could potentially add 2,000 additional Bakken wells each year. And as Scott said, a typical Bakken well, not typical, but high rate Bakken well, can produce up to close to 5,000 barrels of oil a day, 2,700 barrels of oil a day, and this is unheard of on an onshore oil play. The other play that unconventional oil play I'd like to talk about a little bit, it's not as prolific as the Bakken, but it's the newer play. It's the Eagle Ford Formation in South Texas. The small index map on the right-hand side of the slide shows the general location of the Eagle Ford play. It extends across the southern boundaries of Texas. Unlike the Bakken, which has a mixed lithology within the formation, the Eagle Ford is truly a shale play. About 100 to 200 feet of shale that needs to be fracked. There's very little other rock types found in the Eagle Ford Formation. All Eagle Ford wells require horizontal drilling, and all completions require multi-stage fracking. Because of the varying depths of the Eagle Ford, that ranges from about 4,000 feet in the shallow part of the trend to about 14,000 feet in the deeper part of the trend. A productive well will find oil in the northern portion, highlighted in green, wet gas and condensate in yellow in the middle portion of the trend, and dry gas with very few liquids associated with the gas in the southern portion. It's red colored. Examples of the daily oil rates of the oil portion of the trend are shown on the right hand. And again, it's not as prolific as the Bakken, but it's an early emerging play, which will hopefully rates will continue. Many of the operators are not just targeting the oil, but they're targeting the wet gas and the condensate in the middle of the trend, which is the yellow portion. Because these wells produce high gas rates, but they also have a lot of liquids associated with the gas. Not many wells, as you can see, are targeting dry gas. Gas is a low price commodity. A major issue in this play that you'll find is service company availability, products, skilled workforce, and housing. With so many wells being drilled and so many people required to drill these wells, housing has become a real issue in South Texas. And as far as the service capacity, many of the wells in this part of the world, just like in the Bakken, a well can be drilled, completed, but you have to wait months, and I mean months and months, drilled and casing run, but to get your completion, you may have to wait months and months because of the availability of the frac trucks and the products. So how good is the Eagle Ford? Well, you can see as little as 2009, 2010, the whole trend only produced less than 400 barrels of oil a day. Since that time to the present, daily production from Eagle Ford wells has increased to about 750,000 barrels of oil a day. And that trend should continue, especially if we get higher oil prices. The last slide on unconventional reservoirs are what are the keys to success? Well, we know there's large volumes of oil to these unconventional plays. They've been very successful in developing the production technology required to produce these reservoirs. But the real problem with the success right now is stable and high oil prices. What are the issues of these unconventional oil plays? Called midstream capacity. That's the pipelines, the gas processing plants, and water disposal. Pipelines are at capacity. New pipelines have to be built. Gas processing is at capacity. You have to have new gas processing, and service capacity. The materials, frac trucks, and the products, experienced workforce, and support logistics, housing. In the future, optimum well density will be an issue. What's the best well spacing? And the completion and drilling techniques required to make even better Bakken and Eagle Ford wells.